Welcome back, Chemistry 30. So now we'll look at oxidation reduction reactions. So again, we know how to do the oxidation numbers. You've had some practice, hopefully, determining that. Now we need to keep track of those oxidation numbers in a reaction. This procedure identifies whether the oxidation state changes for any elements involved. For example, consider the reaction that occurs spontaneously when zinc is added to a strong acid. All right, so if we look at this, let's assign oxidation numbers first of all. So if I look here, zinc, it's a monatomic atom, so it's a 0, and there is only one zinc, so it's 0. +2 or +1 here for hydrogen. Now I'm just going to exclude this balanced 2 here for a second. There's only one hydrogen here, so one hydrogen. Zinc ion is a 2+ charge, so each zinc is +2. And we only have one of them, so +2. Hydrogen, it's considered an elemental in the an element. It's by itself, 0, 0. So if we take a look at what happens here, zinc starts off at being an oxidation number of 0, and then goes to +2. So now to go to +2, it must have lost electrons. And to lose electrons, remember, lose electrons, oxidation. Now what you may want to do over here is just copy out this little schematic here, which is just simply a number line. So if I went from 0 to +2, that means I did this. And what that is lose electrons, oxidation. So if you lose negatives, you get more positive. Whereas over here, I went from +1 to 0. When I'm going from +1, it's a little bit easier to see what's going on here. When you're going positive and going to the left, obviously you're gaining electrons. So when you're moving this way. And that's easier to see. Gaining electrons, you get more negative. So if I'm going from +1 to 0, that is So this is going to be reduction. And then over here I could say this is oxidized or oxidation. Okay, so if I get more, my atom is getting more positive, it's oxidized. Getting more positive. If it's going from +1 to 0, that's getting more negative. That means we must be gaining electrons. So that's what's showing here. Now, over in this example, they put the oxidation numbers below. I like to put the individual ones at top. So 0, +1, +2, and 0, and keeping the sum on the bottom. So from the oxidation numbers below the equation, we see that the oxidation number of zinc goes from 0 to +2, and the H goes from +1 to 0. Thus, we can say that this is an oxidation reduction reaction because there is a change in oxidation states. Electrons are transferred from zinc to the hydrogen atoms. Therefore, zinc is oxidized and H is reduced. So zinc is oxidized. It's the one that's losing electrons. And what's gaining the electrons? The hydrogen. In some reactions, the oxidation numbers change, but we cannot say that any substance literally gains or loses electrons. For example, in the combustion of hydrogen gas, hydrogen is oxidized from 0 to +1. The oxidation state in oxygen is reduced from 0 to the -2 oxidation state. So over here, starts off as 0, ends off as 0. 0, 0. Oxygen, when it's in a compound, is -2 unless it's a peroxide. Hydrogen is +1, but we have 2 of them, so 2 times 1 is +2. So you can see that these add up to give 0, these are 0, these are 0. Therefore, it's an oxidation reduction reaction. Water is not an ionic substance, however, and so there is not a complete transfer of electrons from hydrogen to oxygen as water is formed. Thus, keeping track of oxidation states is a convenient form of bookkeeping, but you should not generally equate the oxidation state of any atom with its actual charge. So it's a little bit different than using charges. Sometimes we use the charges to find the oxidation state, but it's a way of determining if something is an oxidation reduction reaction itself. In any redox reactions, both oxidation and reduction must occur. It's like the transfer of money. Someone has to be losing money and someone has to be gaining money. The substance that makes it possible for another substance to be oxidized is called the oxidizing agent. The oxidizing agent acquires electrons from another substance, and so itself is reduced. This is tricky, but we'll hopefully see it through the examples. So it's kind of opposite to what you think would be. A reducing agent is a substance that gives up electrons and thereby causing another substance to be reduced. The reducing agent is therefore oxidized. Okay, so with these last two examples here, hopefully we can see that and see how all that comes together. So, example, identifying oxidizing and reducing agents. The nickel-cadmium or NiCad battery uses the following redox reaction to generate electricity. Identify the substances, this should be one word, that are oxidizing and reduced, and indicate which is the oxidation agent and what is the reducing agent. So first, what we have to do is go and assign oxidation numbers for everything. So cadmium is just an element by itself, so it's 0. Oxygen, of course, it's -2. -2 times 2 is -4. And I know the sum here must add up to be 0 because this is neutral. There's no charge up here. So that tells me that this number here has to be +4. And since there's only one nickel contributing, that one nickel is +4. Water, oxygen's -2. I know it must add up to be 0. So that means this must be +2. And yes, it works out perfectly because there's 2 hydrogens here contributing to that +2. So each one is +1 individually. Right. Over here, hydrogen's +1 and oxygen's -2 like we talked about, but we have 2 of each. So we have +2 and we have -4. And we must know that all this adds up to be 0. So we can figure out what number must go here. -4 +2, this has to be +2. And since there's only one cadmium here, that one cadmium is +2. Similarly over here, -4 +2. And yeah, this time the nickel needs to be +2. All right, so let's see what happens here. Going from left to right, cadmium goes from 0 to +2. Oh, there we go. We have something going on. So of course, yes, when you get more positive, that's Leo, lose electrons, you become more positive, which is referred to as oxidation. Oops, don't even know how to make a number line here. So oxidized. And if I look at something else here, notice oxygen doesn't change at all. Hydrogen doesn't change. It's they're -2 and +1 respectively. Nickel, though, goes from +4 to +2. So I'm comparing the top numbers here. Individually, what is changing? So +4 to +2. So as you can see, +4, which is over here on the number line, going to +2, I'm going in the negative direction. That means I must have gained electrons. And of course, that is called reduced. All right? So we should be able to answer this question. Identify the substances that are oxidized and reduced. So first of all, let's look at CD. CD went from 0 to +2. Therefore, it is oxidized. And nickel went from +4 to +2. It's getting more negative. Therefore, it is reduced. And of course, so Leo and Gur respectively there. Okay, continuing on here. Now, to look at what's going on here, so CD is going from 0 to there. Okay, let's take a look what CD is also doing. So nickel is getting reduced. What's causing it to become reduced? It's the CD. So we can say here, oops, let's just do it like this. Let's say CD is the reducing agent since it causes nickel to gain electrons as nickel oxide is converted to nickel hydroxide. Okay, here's what's tricky. So think of the oxidation reducing agent as secret agents. They're manipulating things from off to the side. So to make nickel gain electrons, CD is causing it because CD is giving its electrons to nickel. Okay, so CD is the reducing agent. That's all that we have over there for a compound. It's just cadmium. It causes nickel to gain electrons as nickel is converted to that. Maybe we'll say CD does this by giving nickel its electrons. All right, so CD is the agent. Over here, let's look at now. CD, I know, is losing electrons. What's causing that to happen? Well, it's the nickel oxide itself. You state the whole compound. The whole compound is the agent. So nickel oxide is the oxidizing agent since it causes CD to lose electrons as CD is converted to cadmium hydroxide. Okay, so what happens here is nickel oxide does this by taking electrons from CD. Okay, so think of it as the compound on the side that's causing something to happen. So CD is getting oxidized. What's causing it to happen? Nickel oxide, because nickel oxide is stealing them. And then over here, CD is referred to as the reducing agent because it's causing nickel oxide to become reduced by giving its electrons. So see if you can do the next example. We'll stop the video, then we'll come back and see how you did.